Waleed, thanks for asking this question. I'm glad you did. I hope we get more questions in as we go through the Chapter 4 assignment. Let me read the question. First, from Chapter 4 assignment, a 1.5 kilogram steel mass is dropped onto a vertical compression spring of force 2.1 times 10 to the 3 newtons per meter, I should say, from a height of 0.37 meters above the top of the spring. Find from energy consideration the maximum distance the spring is compressed. So what happens here? Well, you got this ball right here. It's not moving. It's just about to be dropped. And we're told that it's 0.37 meters above the spring. At this point here, the spring is not compressed. Then the ball is dropped. All right, so we're moving away from the initial conditions to the final conditions. And when this ball is dropped, it compresses the spring, and then it compresses it as much as it's going to compress it. It only can compress it so much, and then it stops. So what I'm saying here is in the final situation, the speed is also zero. It drops through the air, and then as it's compressing the spring, eventually it comes to a stop. When it comes to a stop, I'm going to say that right here is y final, all right, which is 0 meters. So I'm going to consider this level right here. I'm going to consider this level right here to be my height of 0. Okay, right there is 0 height. So all gravitational potential energies will be referenced to this 0 height. So what happens here? Well, a couple of things. Let's say that we're going to label the amount of compression, the amount the spring has been compressed by, we're going to give it the value x. Now that is very important because then we know that the object started at a height above this 0 height level that we're going to call h. So h is where the ball started from. But look, we know what h is equal to. This h is equal to this little bit right in here, which we called x, plus the original 0.37 meters that you started with. So now we do have the height of the ball above this 0 reference point, the 0 height, during the initial conditions. So now you are told in the question, it says use energy considerations. Well, I think you all know that means that we're using the law of conservation of energy, that the total energy initial is equal to the total energy final. So you have to go to the initial situation and ask yourself, what energies are present here? Is there any kinetic energy? Is there any elastic potential energy? Is the spring compressed or expanded, stretched out at this point? You have to ask yourself that, okay? Does this object have any gravitational potential energy at this point? Does it have a height when it's there? Then you have to ask yourself exactly the same question about the final situation. So here it is, the final situation. You have to ask yourself, does this object at this point have any gravitational potential energy? Does it have any height here? You have to ask yourself that question. Is there any gravitational potential energy? Is the object moving? Is there any kinetic energy here? And then you have to ask yourself, is there any elastic potential energy here? Has the spring been stretched or compressed by a certain amount? And then you'll proceed through with the question. Okay, I hope that helps. Please ask more questions. I'm here to help you, and we'll talk to you later. Bye-bye.